Okay, so we're ready to do a Math 105 video. This is something like the 29th video, I think. Well, we can check that out soon. Here we go with our paper. And we can almost get started. Just get our pencil. And now we're ready. Okay. So what we're doing now is transformation of graphs, 2.6. It's homework 11. Right. So we're going to do some stuff about transformation of graphs. If we need to do more, we'll have to do more in the future. So again, right here we go. So what I need to do here is show you. I'll put up the title. That makes some more sense to get started with the title. Transformation of graphs. Transformation of graphs, or transformations. Okay, so let me show you 4 prototypical graphs. I'm going to call, I guess they'll do the usual, call them 1, try to get them side by side if I can. Here's something that you've for sure seen before, parabola, starting at the origin. And this function is called f of x is equal to x squared. Classic parabola. Number 2, next door to it. What about f of x is equal to absolute value x? Here's what the classic function looks like. I'll put it underneath. Maybe I can get some more room that way. Okay, the classic function looks like this. It looks like a V. Going down to the origin, going up towards the origin on the right. That is the classic f of x is equal to absolute value x. Here comes classic number 3. There's more than, I'm going to put up 4, I hope, but there's actually more than 4, but for our purposes for the moment, we're just using these 3. Okay, f of x, here it is equal to the square root of x, equal to the square root of x. What does that classic function look like? I have to get a little tighter over here. That classic function looks as follows. It goes like this. And fourth, it's worthwhile for me to try to squeeze here to get 4 on the same line. What about f of x is equal to the reciprocal of x? F of x is equal to 1 of x. That classic function looks like this. Looks maybe a little strange. Looks like it's got 2 boomerangs. It looks like it has something going up like this, getting down close to the origin and veering over that way with arrows. And that's on the upper right. Be sure to remember that it's on the upper right. And then on the lower right, also looks like a boomerang. Of course, in your book, it'll look much better if you look it up. It's in 2.6 for you to get much better drawings than me. Okay, now, what about this transformation stuff? Here's a problem that you can get. 1a, right? And we're going to follow. 1a is going to be pertinent to 1, and then I want to do a 2a. I want to match them up. I think you'll see what I'm trying to do pretty soon. What if you have something that f of x is equal to, there's a minus there. You're not going to see a minus too often, but that minus means the parabola is going to open downwards. But I got to explain that better. I'm just telling you right now. But I got to explain that better in a second. Just bear with me. But even more importantly, which is there right next to the x, you have a negative 3. It's going to be either a positive number or a negative number. I'm putting a negative number there first. Then squared, and then minus 2. Okay, so bear with me for a second. We'll talk about it in a couple of minutes. Then I want to put next door to that. Let's make sure you don't confuse anything. Next door to that, I want to put f of x. This is going to be 2a 2a, right? To make sure that you realize they're related to each other. And here it is. And these are all questions. These are all questions. All this stuff is questions. All right, but anyway, here it is. F of x. Basically, we're being asked. These are questions. And what's the question? We're asked to graph this. Okay. Anyway, 2a, f of x is equal to absolute value, x plus 2, and then minus 4. Okay, here let's put a firewall in between these two problems. Then comes 3a, a little bit of a squeeze. What's the question for 3a? F of x is equal to the square root of x plus 3, x plus 3, x plus 3, square root goes over there, but not any further. Just goes up to there. The plus 2 is not part of the square root. Plus 2 is outside. And it stops there. Okay. That's question number 3, 3a. Question number 4 is 4a. And what does it say for 4a? What about f of x is equal to 1 over x minus 2. That's it. Nothing more complicated than that. You probably wouldn't get something more complicated than that on a test. I don't think, but whatever. We're preparing the basics here. So here we go. Okay. Now, the classic f of x is equal to x squared. So when you see over here an x and x squared, you know it belongs to the parabola family. It's going to look somewhat like this. Just bear with me a little bit. When you see an absolute value, it belongs to the classic absolute value family. So you know it's going to look basically like this, with that V shape. When you see the square root, and then there's x inside, it belongs to the square root of x family, and the shape is going to be basically like this. Again, bear with me. We'll show you soon, hopefully. And when you see a question that has f of x equals 1 over x is on the bottom of the denominator, and then whatever junk it has, it belongs to this one, the reciprocal family, and the graph is going to be basically like this. Okay, now, transformation means it's going to move a little bit. First of all, by minus, when a situation is minus, then it's going to open downwards. Right? So parabola, when parabola normally is good, if there's no minus in front of the x squared, and there's no minus in front of the x squared, it opens regularly upwards. But if there's a minus in front of the x squared, if there would be a minus here, that would have opened downwards. And if there's a minus here, that signals to us that it's opening downwards. Now, where do we start? Here's our information. The opposite of this is going to be where we go on the x-axis. So we have to go 3 to our right. The opposite. And this -2, not the opposite. That, it tells you what it wants. And that means we go 2 down. 2 down. And that's where we're going to get started. So let me show you exactly what I mean. We go to my lousy graph over here, y-axis and x-axis. We move 3 to the right. 1, 2, 3. By the way, one more thing I should have said. That in a parabola, the bottom of the parabola or the top of the parabola has a fancy name called vertex. It's worthwhile knowing that now. We're going to have to know it anyway, eventually. So that's the vertex. All right, so I have that vocabulary word in hand. Anyway, what does it say? This tells me to go 3 to the right and 2 down. 1, 2, 3 to the right, and go down 1, 2. And here's where my parabola starts. So it's going to look this. It's going to have this shape of a parabola. But there's one more thing we got to remember. Since there's a minus here, it's opening downwards. And there is the transformation. And that's it. This problem is done. We're done with this. 1A, done. That's the graph. Okay, now, this is in this family. And basically the shape's going to look like this. But what are my instructions? It says a +2 over here. Take the opposite. Go 2 to the left. It says plus. Don't go to the right. like we're normally used to, go 2 to the left. What does that negative say? Go 4 down. 4 down. All right, let me draw my y-axis, x-axis. There's no minus here or anything like that. Don't worry about that. So what's 2 to the left, right? 2 to the left, start at the origin. What did we do over here? I didn't mention this, but I should have. We started at the origin, 3 right, 2 down. Start at the origin, 2 left. 1, 2, 4 down. 1, 2, 3, 4. Here's where my vertex is. And I do it all the basic shape, that basic V shape, not downwards. I apologize. It's regular. Upwards, V shape. Same V shape here, but put it over, move it, shift it over to the left and 4 down. That was, don't mind that. That's not part of it. Sorry. Okay, same stuff going on over here. This is going to be the shape. There's nothing about negative over here. It's going to be look exactly like that. But what does this +3 tell me? This +3, since it's positive, take the opposite. You're going to go the other side to the negative. We're going to go 3 left. What does this +2 tell me? The +2 we take literally. That we don't do the opposite of the +2. We go up, 2. Okay, my drawing, y-axis, x-axis. Keep this out of the way. X-axis, 3 to the left, 1, 2, 3, up 2, 1, 2. Here's where I start, and there's that arrow. Finally, we get to the last one, 4A. What family is it in? Reciprocal family. It's going to basically look like this. There's nothing telling me about going right or left, but there is something over here that tells me to go 2 down. Take it literally. What? The second one on the right-hand side, we take literally. So that's going down. 2 down. Okay. Draw my drawing over here. Now go down 1, 2. Here's my new x-axis, so to speak. And then draw this drawing here, the boomerangs. Make the boomerang go all the way down to near the -2 line. And have the boomerang start from the -2 line and go like that. And here is my drawing. That is this one, that is this one, that is this one, and that one is this one. And this video is over, an important video about transformations.